So as already mentioned, I most definitely disagree with the textbook on this one. They still want you to use area to solve this problem. I apologize for my pizza being green. That pizza was obviously cut by a beginner. They got to work on their skills a little bit. But apparently there is an anchovy underneath the cheese on one of those pieces. And we want to figure out, and I've added a few. I think yours only says piece 2, correct? Maybe add an A for piece 2, B is slice 5, and C is slices 4 or 7. So piece 2, would you think that having the anchovy on piece 2 up there is going to be very probable? Is it likely that if you picked slice 2, that you would get the anchovy? Not really, right? I think it's obviously that slice 5 is going to be more probable because it's bigger. Well, they want you to go and find the area of that slice and then divide by the area of the entire pizza. Well, we're still going to do success over total, but we're just going to do degrees. How many degrees do you have versus the degree of the entire pizza? And how many degrees for the entire pizza? 360. Isn't that a lot quicker? So piece 2, well, how many degrees is taken up by piece 2? 24 degrees over the entire. So this is success, or getting that one over total. So it still works out that way. It's just a lot less work. How about those degrees? What happens to those in this case? They cancel. Once again, you're seeing an emphasis on me showing you labels and how they work. So it's 24 out of, so if I did it 360 times, the anchovy would only be on there 24 times if we redid this 360 times. But I'm not going to accept that. It gets a little better than that. I think 24 actually goes into 60, doesn't it? Evenly. So it's 1 out of 15. Of course, you could always go to a percent. What is it, about 7%, something like that, or 6.7%, something like that. So not very likely. Only 1 out of 15. So how about slice 5? That's much more likely. Is there anything you can do to that 67 over 360? Does that really go anywhere? No. But you may notice that on all of these, I've even been writing the ones I knew. I knew that one right there was going to simplify, but I wrote it because now I can compare it to the other ones that maybe don't simplify. So I would say this one is almost 3 times more likely for you to get that anchovy. How about the last one, slices 4 or 7? Well, all you got to do is take the degrees for 4 and take the degrees for 7, and add them together. So we got 50 and 39, so we're looking at 89 degrees out of 360 degrees. How about 89 over 360? Anything happening there? Not really. So 89 over 360. Now, if I knew there was an anchovy under one of them and I got to pick first, I'd probably still pick either slice 5 or 1. I would just lift up the cheese and see if it was there and then take it off, personally. So the problem's slightly flawed anyways. But this system works for a spinner. If you had, like we do for the exams, if that spinner was on here, you know, this same thing works for that. What's the probability you don't have to necessarily find area in those? Okay. Any questions? We'd probably still be on letter B if we did it the way the book wanted us to do it. Okay. Which is find the actual areas. And the last one, this is the one you're going to have to add to your notes, so I will pause this for a second while you draw that picture in. I would recommend maybe drawing the triangle first. Hopefully that was enough time to get a halfway decent picture in there. I'm guessing some of your circles are maybe not quite what you wanted, but that's okay. It may look, though, as that I have forgotten to give you information, but I didn't. The funny thing is let's say one of you wants to put a measurement in there and you think it should be, say, 32 miles. And then another one of you says, oh, let's make it 2 inches. As long as that measurement holds for both the triangle and the circle, the probability is going to end up the same because the relationship between the areas will be the same. Okay, are your areas going to be vastly different if you choose 32 miles versus 2 inches? Yes, but the relationship between the two figures will be the same. I don't have to give you measurements. You can make up any measurement you want. Okay, the book probably wants you to actually do it algebraically, but why not just pick a number and go? For a circle, pretty much the only thing you're probably going to want to put in there is the radius of the circle. And you can draw the radius wherever you want, but I think the most helpful place to actually draw the radius in this case is right there, because that radius is also the what for the triangle? The apothem. And that measurement's going to hold for both. So now all we have to do is come up with whatever measurement we want to use. And really, does the label anymore matter if we're just going to divide the areas anyways? No, that label, just like it's been doing all day, is going to cancel anyway, so it really doesn't matter in this problem. And I would say choose a nice number to work with. 17, is that a really good number to work with? Not usually. So what do you want to use? Yeah, 23, that's a great number to work with. Awesome. How about 10? All right. So if we use 10, now I am going to need your help as we go through this problem, because obviously this circle is going to have pi involved. Is the triangle going to have pi involved like that last problem? Everything had pi, right? Not going to happen here. And in fact, that triangle is probably going to have some kind of square root involved. So let's just do the circle first. So area of the circle. And we refreshed our memories here that it was pi r squared. So that if that's the radius, the area of this is 100 pi square units. But again, the units are going to cancel off on this one. But if you are wanting to stay in that habit, you can definitely write that in there. But I just got done telling you that that triangle is not going to have pi involved, right? And what did we do before when we knew pi wasn't going to be in the other one? We just went decimals, right? And so if we take pi times 100, that's 314, and let's probably go to the tenths. So 314 point, let's see, 15, so 2 units squared. I just went with what pi is and moved the decimal. Okay. And once again, if I were you, I'd probably put a box around that so you don't lose it in your work. Because we're not going to use that right away, but we will be using it relatively soon. So now let's just get this out of your way. Do you agree that's the entire target? Is that triangle? You can see now, and there's your 10 being your apothem, which means I can draw this over here. Well, maybe hit it when you do it. What's this angle down here then? 30, 60, 90. And I was a little concerned last hour when I went to go and find the area of this triangle, and people had forgotten that. Perimeter times apothem divided by 2. Remember, you can do base times height, but I don't have that information here. Divided by 2, of course. But I now have 2. I've got the apothem. Can I find the perimeter from what I've got? Yeah. So here I'm across from 30 as a 10, correct? Do I want this radius of this triangle? Is that going to help me find perimeter? Not really. So let's go down here. Again, you can use law of sines if you are not really good at your cheat sheet. But how does your cheat sheet inform you to get to that one across from 60? You got to multiply by something, square root of 3. Now you may remember, this one has a square root of 3. Does my other answer in this one have a square root of 3 involved? No, so probably not very helpful. So let's go ahead and go decimal 17 point something. 3. Is 17.3 my perimeter? It's just that little segment. How many of these little segments again? 6 of them, right? So take 17.3 times 6 to get the perimeter, which I will then put right over here. It's probably pretty big, huh? Yep, 103.8 times 10 is, see why I like 10? You just move the decimal over. 1,038 divided by 2. So 519. And again, if you like the unit squared, that's fine. So now let's just take a little break here. We'll check our time. Oh, we're good. And then, is it okay if I erase this triangle? Everybody sees where that came from, this one down here? Okay. What I'm going to do is I'm going to put that circle back in. So the area of the circle I'm moving back in is what, 314.2? The area of the triangle that I just covered some of it up is 519. What we have to do is we have to find, we want to hit the shaded region. And so if I have to find that, well, we got to figure out that area. So is that 519 or is that 314.2? Well, it's neither one of those. We have to subtract. So we got to subtract out the stuff I actually don't want to hit. And again, it would be units squared because that label doesn't really go anywhere at that point. And I'm guessing it's a 0.8 if you did it right. Just going out on a limb for that one there. 2042. So 204.8, circle it, we're good? Very good. You take that, you do not circle that. That is the area of what I want to hit, so that's being successful. I have to divide that, as somebody said, by the area of the target. So we have to take 204.8, and what is our target's area? 519, very good. And again, it's units squared and units squared, so I told you they were going to cancel, and there they go. Now, is that one that we're probably likely to look at it that way? Probably not. So we would probably go to a percentage on this one. So just take 204.8, divide it by 519, move your decimal point over twice, and do you think that's a legitimate percentage? Yep, 39.5%. If you would have asked me before we started this problem, I would have said probably around 50% somewhere based on the picture. But if you kind of fold this triangle in, fold that triangle in, and that triangle in, do we actually cover up the entire circle? Not really. So the circle actually is a bigger target for us to hit. So that's why the shaded region is actually less probable than 50%. So again, if I sat back there and did it a bunch of times, I would have a 39.5% chance of actually hitting the shaded region. Okay. And notice, did we start this problem with a single measurement? No, we made one up. But the areas were still going to hold this exact same ratio. So if somebody chose those 32 miles or whatever I said earlier, they would have come out with that same answer if they did it right.